Friends, welcome to the exciting world of precast concrete. I'm Prashant Gutsurkar from Stru Engineers India Private Limited, and we are in the business of structural design of precast elements and precast structures. So, you might have followed us on LinkedIn or you might have seen some of our posts related to various case studies or some technical posts. But this time around, we thought we'll do a video instead of an elaborate technical post and talk about the technical stuff that goes into designing a precast structure. So case studies, of course, yeah, we have a lot of case studies that we have done this kind of a structure, that kind of a structure. But what really goes into the success of a particular precast building is the design aspect. So today we have with us my colleague Mangesh. Hi Mangesh,
Hi,
how are you?
pleasure to be here.
Yes, same here. So Mangesh, we have been talking about case studies as I mentioned just now. And I think we have showcased a lot of case studies which show that okay, we have done a data center kind of a thing, we have done a high-rise building, a residential building, schools, and parking terminals and whatnot. But today I thought let's get into the design nitty-gritties of what exactly goes behind the scene, because whether it's a conventional structure or a precast structure, the design is what makes the structure successful and fulfills the utility expected out of it. Now, I've seen you design so many different kind of structures. I've seen you design a data center, parking terminal. But let's take an example today. Okay, how about discussing the nitty gritties of a parking building, a multi-storied parking building? What do you think?
Yeah, that's great because parking structure is a dynamic structure and it has a lot of things to be studied very minutely and in a very careful, cautious way. We have to go for that. So we have to understand the force path through the structure. That's
So basically, see, my intention is that most of the people who might be watching this are already aware of what precast is and what benefits come out of it. Now, for a parking building, typically what is expected is that the building should be ready as soon as possible and people start using it. And what could be better than precast? But then coming to the aspect of a precast parking structure, I've seen two distinct possibilities. I mean, I've seen you designing a precast building using hollow core slabs. I've seen you designing a precast building with double T slabs. So, what differentiates the choice? I mean, what makes you choose a hollow core for a parking building, and what makes you choose a double T for a parking building?
Yes, that's a nice technical depth question. But in that, it's a very simple. A slab is always a slab which transfers the load to the beam, and that beam carries the load to the column, and column to the foundation. That's the very basic about the slab. But totally, when we design a structure, it totally depends on how the structural shape is. Basically, if you can see, the hollow core has many holes in it, and it is a pre-stressed. And in T slab there is a web portion, there is a flange portion. So there is a structural integrity in, like, there is certain design aspect, technical aspects which helps both of the hollow cores naturally. So both pre-stressed slabs have their own pros and cons. But technically talking about the car parking level, there are certain things we have to take care of. First thing is that load is very high, and that is too moving. And secondly, if it is a precast, then there is a lot of necessity is that it should be carried by the crane, the element should be carried by the crane. So crane capacity comes in that picture. So basically when we go for cast in place structure, then the depths of the sections goes higher, so we go for pre-stress. In that, if we go for pre-stress, there is a need for the crane capacity, so the hollow cores have those holes in there. It helps to make that element lighter and makes the crane to erect it properly. That's the main reason for the hollow core usage. For the T slab, T slab is generally used just because in casting place there is a waffle slab kind of structure, where that waffle helps in designing or helps that slab to have intermediate beams. That beams help the load to transfer uniformly to the main beam, and that is the main aspect of the secondary beams, to transfer that load uniformly. So that's the main things which differ from both of that. And if we are talking about particularly hollow core, then hollow core for the parking structure comes around, the thickness comes around 200 to 350. And for the T slab, the flange portion thickness is around 100 to 120. And the whole overall length, height of depth of the slab goes around 400 because of the web portion. And that's where the real game plays for the span, because for T slab we can go for more span, and for the hollow core there is restriction about 10 to 12 meters. That's where we can go. If we go for higher one, then there is a problem over the thickness. We have to increase the thickness more than 450. If it increases, then there is increase in size of the main beam. If the main beam increases, then there is a problem architecturally, which doesn't allow the vehicle movement because of the height, the heavier vehicles which have more heights, XUVs and other things. So that hinders directly to the project cost, because if the height is lesser, then we cannot afford it. We have to increase the height as per architect. So if the height is increased, then FSI goes into matter, and there itself we have to cut short those the floors because of the height. So that hinders there, and so we have to follow certain things. So we have to like gimbal in T slab hollow core, T slab hollow core.
So yeah, of course, you cannot afford to have less number of cars just because you want to make a structure which is as per your liking. So coming back to this hollow core, now you said since there are hollows inside the element becomes light. So does it also affect the load carrying capacity? So if I compare a T beam with a hollow core slab, then maybe the hollow core has a lesser weight carrying capacity. So what is the alternative? I mean, if there's no double T slab available, because see, in a precast structure you need to get the elements to site. And if there's a case or a scenario where you're not getting double T slabs, of course this is known to the project engineer beforehand. But if that is a limitation, then how do you manage with hollow cores?
Basically, first thing about the mold planning, where hollow cores are manufactured in the factory and where the T slab are manufactured. T slabs has a web portion, so that has a very particular thickness, particular all this. There are a lot of particulars in that T slab, so that's why T slab is not so common in manufacturing. But hollow core is just a plain. It has a hole. That all this instrumentation is already ready, and it's very plain. So it's easily available everywhere where the pre-stress or pre-casting is done. So hollow cores are mainly available everywhere. That is the major factor of the cost. So if and that also to the transportation, it goes to the transportation of that element to that site. So that is one of the point. Second point is, if we go for a hollow core slab, the part I can show you in the laptop itself. Like here is, if you can see the screen, here is the vehicle, and here are two slabs which are inclined. So due to that, uh, the vehicle is going down in this picture. So the CG goes down to the front wheel, and so whole weight of the vehicle, or more of the vehicle weight, is gone on to the front wheel. So that is where the maximum load is acting on the hollow core or the slab. But when it applies, actually when we design it, the wheel loads are dispersed into the slab, and that dispersion should be so uniform that there should be no disruption. And that disruptions causes a lot of weaker sections when we are using that slab in a slanting region. Or we can say in the parking structure we are using this hollow core in the ram section. So basically it crushes down. So for prevent that crushing, we need to fill these holes with concrete. So it cannot be done in the on in the factory. It should be done on the site. So at that time it's not possible because it already erected. We cannot make a hole and just fill it. So it's very difficult. It is possible, but we cannot say that we'll be acting on this hole only. We need to fill all the holes. So it's not possible. So basically there it goes, like we have to think on a more finite way.
Okay.
But if we go to the T slab, in T slab there is a very simple way and a very basic logical thing in structural engineering, that force transfer from slab to beam, beam to column. Same thing happens in the T slab. When the force acts on the slab, it directly transfers the load to the beam, which is web portion of uh, the slab, and this transfers to the column. That is very simple, and that is where there is no disruption. Lot of disruption of there is a hole like rectangular hole, but it doesn't matter a lot there because we are giving certain amount of reinforcement at the top.
Yes,
For
and
the T
there's a
slab.
solidity aspect also to a double T,
Yeah.
which is not there in the
And
hollow
the intermediate beams are there at 1.2 1 meter kind of, depends. And so that's why most of the time T slab are used for the longer span as well, because beam is there to support that slab.
So which means you can get a better parking capacity if you're using a double T.
Double T,
Because
right.
the column spans are large.
Yeah, we can use if double T is available, we can use it in ramps as well as
Okay.
we can use it in the main parking area as well. That's the main factor.
But the earlier thing which you said, that okay, filling the hollow core holes with concrete, I mean that is a kind of an improvisation.
Improvisation.
Which is not very practical.
Practical, yes. Practical, as well as we have to think on theoretical way also.
Okay.
We have to check it in the softwares if it is happening or not. We have to think that, because the casting time of the hollow core is different and pouring time in the hole
Yeah,
is very different. So
Yes.
it may act in a different way.
Hmm.
And second part of T slab is like when we support that T slab on the beam, there is, I can show you the picture as hollow core is kind of plain structure. So if you see the beam, it has a very uniform notch where the hollow core is supported. Whether otherwise in this double T slabs, we have to think on a different way. We have to give a notch in the T slab. If you can see it here, we can see that there is a kind of a notch where we have to support it because it's not uniform, and those beams are supported there, and that is where it helps. Only beams transfer the load. Slab doesn't transfer the flange portion of the T slab doesn't transport the load. Only the beam transfer. Yeah. So that's why the things are that this is a difference in this two slabs.
And does it make, because the connections are very important in any precast structure. So if you compare the ease of connection, I mean, which is easier? I mean, a hollow core or a double T?
In connection wise, basically hollow cores are just a kind of structure slabs, so it can be just put in,
So they'll just
rest on it. And for seismic kind of conditions, we have to give certain reinforcement there, and which can be done in the screeding as well, or opening the cores, which are the holes in that part. We can open it and just fill the concrete there. That is what I'm talking about. Hollow core where we fill it on site, but it happens only in plane, not in the slanting portion, because the story differs there in the slanting portion. There where connection between the hollow core and the beam is, it is for shear carrying capacity, which is acting with the surface. And second thing, for the T slab, it's already beam there, so beam is supporting on the beam, and already the small slab which is 100 thick, 120 thick, it is directly transferring to the beam. So it's not a problem, a big problem there. But it helps also the shear. We do not need to open the cores, or we do not do any cast in place matters there. Just we have to grout, do the screeding, done. That's the simplicity of both of the things.
So what I understand is there's no point in improvising, filling concrete into the hollow core holes, okay, at site. Secondly, if you're not doing that, then a hollow core slab is not really recommended for a ramp because of the distortion it can cause, the change of center of gravity.
Yes, and the crushing of the concrete, that may like concrete is more governing to the crushing or compression. So it helps to hinder that, resist those things happening. So if the core is there in that place, then it may crush, crack, anything can happen. We cannot judge it. To just study those things, we need to have a micro study about that. We have to check all the probabilities happening, like wheel is on this place, what will happen if it is here, what will happen. So there's a lot of study. Instead of going there, why not go for a cast in place slab if you don't have T slab available?
Slabs, yeah. Okay.
So that will be a good question, good thing to go for.
So it will be more of a hybrid kind of a thing. The rams will be cast in place, and these horizontal slabs will be hollow core. Yeah. But then, as I get it, okay, for the very heavy vehicles, maybe a double T
Is more
structure would,
preferred.
be preferred.
Yeah,
Yeah.
more preferred, but still there is a problem about the availability of the T slabs. So many times I've seen a lot of people going for waffle slab which are cast in place,
Okay.
or going for a post tensioning slab.
Okay.
That happens, but there again comes the time span of completing that structure. Because if only we go for column can be casted in very less time. But if the slab is not casted on site, what's the use of casting whole of the columns of whole structure? So there goes a lot of things there. So plus point of having less cast in place, more precast, will save our time more.
Yeah.
Because most of the casting is done when foundation is in place of the
Yes,
structure.
yes, yes.
So it helps to save the time of the cost of the project as well, and complete the project on time. That's the plus point. And about the seismic part, like many times I've heard about the seismic, that precast structures are not good in seismic regions. But there are a lot of solutions for that. Asia, like American structures, New Zealand countries are using precast, but they are doing emulative joints,
Yes.
where uh, joints are filled on the site. So that can be happening.
So it's precast most of the time, but then on the site you're making it into a more homogeneous
Homogeneous
kind of a
structure, yes.
structure. So which makes it act as if it's a conventional structure.
But there we need to have a nice structural analysis there.
Okay.
A lot of inert study about the seismic vibrations and seismic lateral forces, how it's oscillating, how it's happening. We have to study on that. And there are like today we are going through those things. So there are a lot of development going on there in that case. But most of them goes for casting place connection casting.
Okay. So I think this was an interesting explanation or comparison. So let's say I'll just put one last question. If assuming that you have both the type of slabs available for the structure, and you're told, okay, let's have a parking terminal for 2,000 cars. So in that case, what are the aspects you will consider before choosing which type of slab to go for? So what are the core aspects that you may consider?
If we consider as a project cost kind of way, then we will all be obviously see which is available more there.
Okay.
Secondly, if we go for technical part, then obviously we'll think about the loading which is happening there, and which is like helping us to economically design those elements. That is the more factor. But most of the things, like if we go for T slab, we can go for higher span. Hollow core, we can go for less span. So accordingly we can design it, gimbal it, or we can use both of the slab if both things are available on the cost wise. But basic thing is like doing a proper 2D, first 2D analysis, going for what is the cost for that. Then after all the things are okay, then going for a 3D analysis and doing proper study about the what will happen, what will happen if we do it like this, thinking on the practical aspects if the forces are coming like this.
The real life simulation of
Yes,
all types
all
of
the
forces
struct-
that could act on the structure.
Yes.
So you do it on your screen first,
Yeah.
and once you're satisfied, you can say, okay, fine, this is good to go.
Yes.
practical
We have to
design.
satisfy the codal provision of that local area.
Yes, yes, yes.
So that is very important. Many times I've not seen those things happening.
Yeah. Okay.
But here we do it.
Hmm.
We have to do it because we have a lot of things to think about. Like life is more of the life
Yes,
is
yes.
depending on the that structure, and it is a basic aspect, shelter of our human beings. So shelter is depending on that. So we have to go for proper designing, proper using of codal provisions, which is provided by the codal provision locality codes. All those things aspects we have to think on that.
So it's a very good example I think we took because, as you said, it's a dynamic structure.
Yeah.
So it's not something where static loads are going to be
Yes.
present.
Yes.
I think next time we'll take a case of a static load kind of a structure,
Yeah.
which is maybe a data center kind of a thing.
Yeah.
So we'll try to have a discussion on that.
Sure. Sure.
And thank you for those illustrations. I mean, we could
Yeah.
understand how the forces act if there's an incline.
Yeah.
Uh, so it's very good to have you here.
Hmm.
Thanks for sparing time for this discussion, Mangesh.
Yes, it's
Thanks a lot.
your pleasure. Yeah, thanks.
Yes, so friends, today we saw a comparison between uh, a hollow core slab and a double T slab for a parking structure building. So, especially if it's a multi-storied parking structure, what are the aspects which go into the choice of elements for any precast structure? So, I think Mangesh was able to explain it quite clearly, and we look forward to having more such technical discussions. Thank you. Thanks for your time.